हेलो चोल सो वेरी गुड इवनिंग एवरीवन। कैसे हैं सब लोग? आई होप यू ऑल आर गुड एंड डूइंग वेल एंड सब कुछ आपका बढ़िया से चल रहा है, एकदम सही से चल रहा है। तो एक बार फर्स्ट ऑफ ऑल एवरीवन टेल मी, इज माय वीडियो क्लियर टू ऑल, वॉइस क्लियर टू एवरीवन, एवरीथिंग इज क्वाइट क्लियर, देन विल मूव ऑन। यस, गुड इवनिंग टू ऑल, गुड इवनिंग एवरीवन. If the voice and the video is clear to everyone, we'll move on with the questions, because today I'm going to start the revision through questions, and we are going to cover all the important topics which are required to study the strength of material. Yes, good evening everyone. Good evening Aditya, Bhavik, everyone. Good evening to all. Yes, so everyone please join fast and then we'll start the session. Please give me the confirmation if the voice and the video is clear to everyone. Yes, all clear. Very good. Very good. बहुत बढ़िया. Right. Good, good, good. Okay. So let's start the session. Let's start the session without wasting much time. Right. Let's start the session. As I told that you are not going to face any single point where you are going to see that there is any wastage of time or anything like that. We are going to directly start with the question. Everything is cleared. Okay. So let's move on with the question. And as I told that, see, in this particular session, we are going to cover all the important concepts first. Like what can be the possible questions? Yeah, the IT Kanpur, what can be the things that they can bring in the particular question, right? Or what can the variations that they can bring, what can be the favorable topics that they are going to take, that I'm going to cover. Let me inform you, there are two sessions today. There is one session where I will take in roughly around 15 questions, and day after tomorrow, that is not day after tomorrow, tomorrow itself, on the gate wala MECHC, I will be taking pure around 18 plus 12, 30 questions in the session, right? So that is tomorrow at 7 p.m. So we are going to see that. Okay. Okay, so let's move on. Let's move on. And the first topic which I'm expecting this year is thermal stress in tapered cross section. Thermal stress topic in tapered cross section. This is the first topic which I think they can ask this year. Right. So, are you ready for the question on this? Yes. Are you ready for the question? Yes. So let's start it. Let's start for the first topic that I told, that is thermal stress in the tapered cross section. Might be that you have already solved the question, but make sure you are reading the question very clearly. Okay. Good evening everyone. Okay. So question is in front of you. I will be giving you 3 minutes to answer this question. Now we are going as per the gate standard, as per the time that the gate will be in the gate that you will be having for you. So we'll be going as per that. So 3 minutes per question I'm going to give. Okay, I'm going to give 3 minutes per question. Read the question carefully and solve it. Read the question carefully and solve it. All these are new questions, my dear friend. All these are new questions. Please solve it, everyone. A circular bar of uniformly tapering section of length 2 meters is subjected to the temperature rise. Temperature of the rod is increased by 100 degrees centigrade, initial temperature 20 degrees centigrade, which is fixed at both the ends. If the maximum and minimum diameter of the rod is 100 mm, 50 mm respectively, the value of the maximum stress in the rod. क्वेश्चन देखने में बड़ा सिंपल लग रहा होगा, है ना? और है भी. It is simple. There is nothing as such that you don't know. Please solve, everyone. 1590.4. Bhupender Kumar. Okay, let's see. Let's see. These others answer. These others answer. Last 1 minute. Good evening, Rupali, Priyanshu, Rahul, Ayash. Okay. Sir, 3 minute over. पता चला time? Have you understand that 92? B Gautam. Have you understood that 3 minute gone? Very simple question, right? Very simple question. 3 minutes over. This is what happening to you in the test series. Is this happening to you in the test series 192? Is this happening to you in the test series? Tell me yes or no. Is this happening to you in the test series? So we are lagging with the time. Our speed is slow. The calculations are very slow. So what to do? What to do at this point of time? You need to practice more and more. The question is very easy. Question is very easy. There's nothing else that you can't solve in this question. You can easily get the answer. You have solved this question so many times. But when it comes that you need to solve in this particular amount of time, then comes the problem. Let's come to the question first, then we'll talk. So the question is, a circular bar of uniformly tapering section of length 2 meter is subjected to a temperature rise. The temperature of the rod is increased by 100 degrees centigrade. Initial temperature is 20, which is fixed at both the ends. Okay. If the maximum and minimum diameter is 150 mm respectively, value of the maximum stress in the rod will be. Now see here, I think most of you have not seen that alpha is equal to 12 into 10 to the power minus 6 per unit Kelvin. My God, it is not per degree centigrade. It is not per degree centigrade. It is per unit Kelvin. How many of you haven't seen that? How many of you haven't seen that? It is per unit Kelvin. I've told you all these are new questions, sir. It is per unit Kelvin. How many of you haven't seen this? This is per unit Kelvin. This is not per units, per degree centigrade. Yes? Most of you haven't seen that. I'm quite assured of that. Okay? I'm quite assured of that. Most of you haven't seen this. It is per unit Kelvin. Agreed? This is what happens. I always tell, read the questions properly. Coming to the next. E barabar 2 into 10 power 5 megapascal, and yielding of support is also there. Yielding of support is also there. So the amount by which the yielding occurs, will there be any thermal stress? Thermal stress will develop only when the deformation is prevented. Right? So coming to the question now. First, let us note the data. So the length is given as, it is said that it is a tapered. It is said that it is a tapered, right? It is a tapered. It is tapered circular, fixed at both the ends. So let us say there is one end A, the other end is B. The length of the rod is given as 2 meter. The length of the rod is given as 2 meter. Next, it is said the temperature is raised by 100 degrees centigrade. Here also the students will commit mistake. Why? They will see, sir, initial temperature is given 20 degrees centigrade. How many of you have taken delta T as 80 degrees centigrade? How many of you have taken delta T as 80 degrees centigrade? Yes? How many have taken delta T as 80 degrees centigrade? They have not taken 100. They have thought that there is a final temperature is given as 100, initial is given as 20, so the delta T will be 80. Yes, you have done that. You have done that. But read the questions. Read the question again. It is said that the temperature of the rod is increased by 100 degrees centigrade. The temperature of the rod is increased by 100 degrees centigrade. That means it is not the final temperature. It is the delta T that is given to you. I hope you understand now. It is a delta T that is given to you. So it is not 80, my dear friend. It is 100 degrees centigrade. The 20 degrees centigrade is the bogus data. It is not required. That 20 degrees centigrade is the bogus data. I hope you understand this now. Small parts that you need to take care of by reading the question properly. Now coming to the next part. So this is the bogus data. Maximum diameter, minimum. But take one D1, other as D2. So let's say D1 as 50 mm and D2 as 100 mm. D1 as 50 mm and D2 as 100 mm. Right? I hope you are enjoying, right? You are learning what you have to do in the questions. Now, as told, determine the value of the maximum stress in the rod up to 2 decimal places in megapascal. It is said that there is a yielding of 1 mm. There is a yielding of 1 mm. Right. Now, my dear friend, the thermal stress will develop. The thermal stress will develop when the strain is prevented or when the deformation is prevented. Yes. If it is a free expansion, for free expansion, for free expansion, what will be the deformation, my dear friend? For free expansion, the deformation will be L alpha delta T. Now, the alpha is not with respect to degree centigrade. It is with respect to Kelvin. Right? It is with respect to Kelvin. So length I am writing as 2 into 10 to the power 3 so that I get in mm. Alpha is 12 into 10 to the power minus 6 per unit Kelvin. Now I need to convert this temperature in Kelvin. What I need to do? I need to add with 273. You can add 0.15, but that is okay. We can neglect that. So it is 373 Kelvin. So it is 373 Kelvin. What value you are getting, my dear friend? What value you are getting? You are going to get certain value, right? You are going to get certain value. So what value you are going to get here? Please solve fast. Give me the value. Please solve fast. Give me the value, my dear friend. So 2 into 10 power, that is 24 into 373 multiply with 10 to the power minus 3. 24 into 373 multiply with 10 to the power minus 3. Yes? Yes? 24 into 373. So the value is 8.952 mm. The value is 8.952 mm. Right, now there is a yielding of support. There is a yielding of support, right? So the deformation prevented. The deformation prevented. Deformation prevented will be what? Prevented will be what? Nothing but 8.952 minus 1. Nothing but 7.952 mm. Yes or no? Yes or no? Itna deformation. This deformation is prevented now. Now, my dear friend, we all know if I apply the load of P, that is axial load. If I apply the load of P, so this deformation, if I say this delta net must be equal to for the tapered circular rod subjected to the axial load of P having the diameter of D1 and D2 and of length L. It is what? PL divided by pi by 4 D1 D2 into E. Yes or no? Tell me, my dear friend. Tell me, my dear friend, yes or no? Now, you got the value of P now. You got the value of P now. P value is how much? Delta net, I'm not going to solve right now, not required. Pi by 4 d1 d2 into E whole divided by L. Whole divided by L. I'm not going to put unit any. I'm not going to put any unit right now. I'm not going to put any unit right now. I got the value of P. Once I got the value of P, I want to find the maximum stress. I want to find the maximum stress. And to find the maximum stress, nothing but load upon minimum area. Load upon minimum area. This I've already discussed with you all. So what is the load, my dear friend? The load value I've already done, delta net into pi by 4 d1 d2 into E whole divided by L, multiply with, here it will be what? It will be what? Pi by 4 into d1 square. Pi by 4 into d1 square. Agreed everyone? Agreed everyone? Very simple, my dear friend. Very simple. So you can see here the points are going to get cancelled out. You got the value of delta net as 7.952 mm. You got the value as 7.952 mm. Multiply with the d2, that is 100 mm. Put everything in the same units, my dear friend. d1 you are going to write as 50 mm. Length is 2 into 10 to the power 3, right? And E will be how much? E will be how much? E is how much? 2 into 10 power 5 megapascal, that is Newton per mm square. 2 into 10 to the power 2 into 10 to the power 5. So this answer you are going to get in megapascal. Yes, this answer you are going to get in megapascal. What value you are getting, my dear friend? What value you are getting? If I cut here, I get 10, 500. What value you are getting? Yes, are you getting 1590.4 megapascal? If you like the question, I need to see only heart symbol in the chat section. If you like this variety, if you want me to solve, sir, only this type of question in the class, so that we understand where we are going to commit the mistake in the exam, so that we understand how to improve the questions in the exam. Sir, everyone say that, sir, improve, analyze the question, but sir, where to analyze? Who is going to tell where to analyze? We are there to tell you how to analyze. These are the things that you need to analyze when you are writing the questions in the exam, right? Yes. These are the things that you need to analyze if you want to write the question in the exam. You will never see it anywhere they are going to tell these points. Nowhere they are going to tell these points, my dear friend. You will never understand how to improve, right? This is a place where great Wallah team Drona is standing for you at each and every moment. Okay. Repeat 273, but here, if you convert degree centigrade into Kelvin, you need to add 273. That is, basically it is 273.15.15. We are neglecting 0.15. Okay. Are you ready for the next topic? Are you ready for the next important topic, my dear friend? Yes. Same will be coming for all the subjects. Same will be coming for all the subjects. All the teachers will be taking this type of sessions, my dear friend. Yes, yes, yes. Okay. Are you ready for the next? Are you ready for the next? Okay. So let's move on, my dear friend. The next topic is strain energy due to axial loading, which I'm expecting that can come this year, right? So the next topic is strain energy due to axial loading. Are you ready with the question, my dear friend? Are you ready for the question? So let's solve it. Again, I'm giving you 2 minutes, not more than that. Okay. First, look at the question. First, look at the question, everyone. First, look at the question. It's MSQ 1 mark. It's MSQ 1 mark. Have you taken a screenshot first or something? Please take a screenshot because question is in the next page. Or what do you do? Just write the question. Just write this. Just write this in your copy first. Just draw this in your copy first. Then I will show the question. Just draw this in your copy first. Once done, please press thumbs up so that I can show only the question then. First, draw the diagram. First, draw the diagram. Once you draw the diagram, I will show you the question and will start the timer. And then I will start the timer. Because most of you will not be having two mobiles, right? Done? Everyone taken the screenshot? Everyone taken the photo or you have drawn the diagram? Right. See the question. Now I'm starting the timer for you all. I'm starting the timer for you all. I will be giving you 2 minutes for this. I will be giving you 2 minutes for this. Please answer everyone. We'll be giving you 2 minutes for this. It's a multiple select question for 1 marks. Okay, let me increase. I will give you 3 minutes. It will take time because they are both strain energy as well as the other. Shivam, for you, I'm showing this. Please note fast. Just take the screenshot. Shivam, just take the screenshot. Done. Okay. One meter long bar subjected to the axial pull P, which induces a maximum stress of 150 megapascal. The area of cross section of the bar is 2 × 10⁻⁴ per meter square over a length of 0.95 meter and a central of 0.05 length. The cross section area is given. E is given to you. You need to select which of the following 4 are correct. You need to select which of the following 4 are correct. The system is subject to the pull of 15 kilonewton. Strain energy stored in the bar is 2.95 joule. System is subject to the pull of 30 kilonewton and strain energy is 2.95 newton mm. Again, the game is on the units. You need to understand. Last 40 seconds. A and B. Deepak is saying A and B. Okay, let's see the answer. Let others answer first. One person answered till now. The others answer. Shivam is saying only A. Okay. Rishabh is saying A and B. Giving you last 10 seconds. Bhupender, A and B. Aditya, A, B. Wow, good, good, good. Very good. See, if I look at the question, my dear friend, it is said it is a 1 meter long bar subjected to the pull. Does not mention the value of the pull, just said it is P. Is noted by a symbol that is P. Okay. Next part, it is said that the maximum stress is 150 megapascal. Now you tell me where the maximum stress will develop. In the central portion or in the outer portion? Where the maximum stress will develop? In the central portion or in the outer portion? Yes. Answer everyone. The area of cross section is given in the figure. Okay, length is also given. You have been asked what is the value of the pull and what is the strain energy in the bar. In the central portion, because the area is minimum in that portion, right? Yes. Now, if I solve this question, can everyone be assured of this, that the load on each part of the bar will be P tensile? Can everyone ensure me that the load on each part of the bar is P tensile? Yes or no? In each and every part of the bar, if I take, whether you take the extreme or you take the central, the load is P tensile. Yes? Obviously. Now, I decide that sigma mass will be seen in the second part. So I will take its area, that is load upon area minimum, because we are talking about the maximum stress. So 150 megapascal is equal to load that I need to find, and minimum area is mentioned. Let's see. Look at the units again. You have been asked in terms of kilonewton. You have been asked in terms of kilonewton. So let us say this is in kilonewton. So I will convert in the Newton. Right. Area is given in meter square. I need to convert in mm square. 1 meter is 1000 mm. So if it is squared, 1000 is squared, 10 power 6. So if I look here, 10 to the power 2, cancel, 0, 0, cancel. The first part is very easy. It should not take much time. The first part is very easy. It should not take much time. I hope everyone has got this value. I hope everyone has got this value. The first part is 15 kilonewton. That is correct. But you also need to determine the strain energy. But you also need to determine the strain energy, my dear friend. So let's see now. Let's see now. What is this strain energy all about? Let's see now what is this strain energy all about. Right. Now, see, if I look at the strain energy, I can say, let us divide this in two parts. Because for the central, area is different. For the central, stress is different. Right. So, what I can do, for this part, I can write sigma 1. For the second part, I can write sigma 2. Yes or no? Hey, tell me, Baba, yes or no? Yes. Now, the load is same for all. So, I can say that sigma is inversely proportional to area. Sigma is inversely proportional to area. If I can say like this, I can say that sigma 2 or sigma 1 by sigma 2 is equal to A2 by A1. That is nothing but 2 into 10 to the power minus 4 divided by 1 into 10 to the power minus 4. Nothing but 2 times. So sigma 1 is 2 times sigma. That is 2 times sigma 1 is 2 times sigma 2. So I hope you understood the value of. I hope you understood the value of. Here, this is sigma 1. So now from this, what is the value of sigma 2, my dear friend? Nothing but sigma 1 by 2. That is nothing but 75 megapascal. Yes or no? Tell me fast. Yes or no? It is nothing but 75 megapascal. I'm not going to write the value of P square L by 2 AE and something like that. I'm going to make it very simple. That I know the value of sigma 1. I will get the value of sigma 2. What I'm going to write? U, if I give the name, I'm dividing two parts, U1 plus U2. U1 for sigma 1, U2 for sigma 2. So I will write this as what? Sigma 1 squared divided by 2E multiply with V1 plus sigma 2 squared divided by 2E multiply with V2. Can I write like this, my dear friend? Can I write like this? Strain energy formula, sigma square by 2E into volume when subjected to the axial loading. Yes? So I know the value of sigma 1. I know the value of sigma 1. How much? 150 megapascal. So 150 square. What is the volume? What is the volume? So I will convert in mm. So if I convert in mm, what is the value? This value is nothing but 10 square, right? This value is 10 square. And this value obtained as how much? Area. This area is how much? 200 in terms of mm square. Okay. So the value is how much? 100 multiply with what is the length? 0.05 meter. Nothing but how much? 50 mm. Yes or no? So multiply with 50. Whole divided by 2 into what is the Young's modulus? What is the Young's modulus? 200 gigapascal. So 200 into 10 ka power 3 plus sigma 2 square, that is how much? 75 square upon 2E, that is 2 into 200 into 10 ka power 3. If I come to the area part, that is nothing but 200 multiply with what is the length? The other part, that is nothing but how much? 950, my dear friend. Can you get the value? The value that you are going to get will be in Newton mm, and you have been asked in terms of joules also. So you need to be very careful with the answers, right? You need to be very careful with the answers. Akshay, you can't write directly U1 is को 2s कर दे because the loads are different. The loads are, and there is a square of sigma. There is a square of sigma. What is the value, my dear friend? What is the value? If you're solving this, this is coming in Newton mm. This is coming in Newton mm. The value that you are going to get here is in the Newton mm, my dear friend. Mind it. The value that you are going to get here will be in Newton mm. So you can't commit mistake over there. What is the value you are getting? What is the value you are getting? Please answer, everyone. Please answer, everyone. Yes? What you are getting, my dear friend? You must be getting around 2.95, or you must be getting around 2950 Newton mm. Are you getting this, my dear friend? Are you getting this? 2950 Newton mm. Right? So, if I look here, obviously this D statement is wrong, and we convert in the Newton meter, it will be 2.95. So the correct answer will be A and B. The correct answer will be A and B. Yes, almost everyone answered this question. I'm very glad to say that. Yes. Maza aaya. Have you enjoyed it? Have you enjoyed it? Second question, sir. This is just a second question. This is just a second question. Yes. Okay. So let's move on with the next question. Next part that I feel that can come will be stresses in composite section. The next question that can come from a topic is stresses in composite section. So let's start with the question, my dear friend. Directly, let's come to the question. Please answer, everyone. Giving you 2 minutes for this. Not 2 minutes. Let's give you 3 minutes only. Yes, solving 3 minutes, my dear friend. Prana, already that PYQ PDF is shared. Just go to the app. Please solve, everyone. Composite bar fixed at both ends, made of aluminium and steel. Cross-sectional area of aluminium is twice. Put full stop here. Cross-section of aluminium is twice the cross-section of the steel, which is represented by area A. बहुत easy है, कुछ hard नहीं है. There is nothing as tough. Everything is very easy. If you think it is tough, it will be tough. If you think it is easy, it will be easy. Okay. Now here is a game which you are going to take area A for aluminium or for steel. You need to understand the language properly, what it is saying in the question. You need to understand that. You need to understand that. What language has been asked. .95. Pratyush Sahu is saying 0.95. Okay, we'll see. We'll see what others are saying. Still 40 minutes left, 40 seconds left. 0.57. Sahu has changed his answer. Oh, some other Sahu. 0.57. 0.858. Shivam is saying 0.858. 0.833 Bhupender. Okay. Go with the basics. Always rely on basics, my dear friend. Don't be in a hurry to answer. 856 Snehilata. Okay. Let's see. Let's see. Two answers are matching. Okay. Let's look at the solution then. Let's look at the solution then. Shall we look at the solution now? Shall we look at the solution, my dear friend? It is said a composite bar fixed at both ends, made of aluminum steel, cross section of aluminium is twice the cross section of area of steel, which is represented by A. That means, is it saying the area of aluminium as A and area of steel as A by 2? Yes or no? Area of aluminium as A and area of steel as A by 2. Now, my dear friend, the first part, the most of the students must have committed mistake here itself. Most of the students must have the committed mistake here itself. Yes. Yes. Most of the students must have committed mistake here itself. Now, the next part is the axial load P is applied at the junction of the aluminium and steel bar as shown below. Elongation in the length of the aluminium bar. Very easy question. Very easy question. So we need to rely on the basics, my dear friend. I always tell you, whenever such question come, you need to assume the support reaction in the direction opposite to the net applied load. So if I apply the load P in the right direction, I will assume the reaction as what? This as PA, right? And here I will apply as P. If I give the name, this is ACB, I will write this as PB. The game is of free body diagram. Yes or no? The entire game is of free body diagram. So, coming to the free body diagram, my dear friend. Coming to the free body diagram. So, there are two blocks. Just draw the blocks as it is. Just draw the blocks as it is. Okay. Now, I've told you, show the loading which is in the external first. So, this is your PA and this is your PB. I hope this is the only direction I put. Yes. Now, if I'm moving left to right, the junction load I will show on the right portion. Very good. From the equilibrium equation, we know that PA plus PB must be equal to P, right? Obviously. Now, if I balance it, left balance by right, that is PA. Joint balance, it is PA. Now, if I need to balance this should be net direction. That is nothing but P minus PA. I hope everyone must have done this very correctly. Right? Now, this is AC. This is your CB. It is a fixed end. So, delta AB must be equal to 0. That is delta AC plus delta CB must be equal to 0. So, I talk about the delta AC. I talk about the length L by 2 and there it is L. Here also you might commit mistake. L by 2, here it is L. The area is A. Here the area is A by 2. Right. If I talk about the Young's modulus, so E steel is by E aluminum is 20 by 7. So here it is aluminium. This is your E aluminium. Here it is E steel. You need to take care of each and every point while you are answering. Okay. Now, so here, if you talk about the load, it is PA. It will be tensile. Length is L by 2 upon area is A into E aluminium, right? Minus, or let's write plus. Obviously, it is in compression. I will write as minus of P minus PA into length of L upon A into E steel. How many have written this statement very properly? How many have written this statement very clearly? How many have written this statement very clearly? Because if you have committed mistake here, you can never get the correct answer. How many have written this line very clearly? No mistake in this part. No mistake in this part, my dear friend. Correct? Correct? Yeah, this area will be A by 2. Now, so if I see here now, so PA into L by 2, that is equal to A into E aluminium will be equal to, I'm taking our opposite side, P minus PA into L divided by A by 2 into E steel. Very good. So it is said that E aluminium by E steel by E aluminium is 20 by 7. So if I cut here, I will write this as 20 by 7. Very good. Area cancel out. I am writing 2 upper side. Writing 2 in the upper side. Okay. Then here the 2 is there. If I cut from here, I will multiply here with 2. L cancel out. L cancel out. So I will get the value as PA is equal to P minus PA into. This is how much? 210, 25. Nothing but 7 by 5. Okay. So if I take it that side, 5 by 7 plus PA. 5 by 7 plus PA. That is nothing but 12 by 7. Yes or no? 12 by 7 PA is equal to P. So PA is nothing but equal to 7 by 12. Are you getting this value? Are you getting this value? PA is equal to 7 by 12. Tell me, my dear friend. Are you getting the value PA is equal to 7 by 12? Is this the value you are obtaining? Just tell me. Yes? If you are obtaining this, my dear friend, now it has been told you got the value of PA now. It has been told to find the value of elongation in the aluminium. So that is in this bar. So delta aluminium, if I write delta aluminium, what will be delta aluminium? Load on aluminium, that is PA upon area aluminium, right? So PL by E, that is L by 2 E aluminium. Okay, E aluminium. Again, you need to see here, it has been written in terms of E steel. So if I need to replace E aluminium, I will write E aluminium as what? E aluminium is 70 by 20 of E steel. So you need to replace this very properly. So PA is how much? 7 by 12 of P into L by 2. Area aluminium is nothing but A. E aluminium is how much? 7 by 20 of ES. 7 by 20 of ES. Yes or no? Yes or no, my dear friend? Tell me, re baba. Yes? Now, so you need to write PL by AES. So you need to take out the common terms. It is coming out to be 20 by 24. 20 by 24 of PL divided by AES. So this is nothing but 4 5s are 20, 4 6s are 24. So this value is written as alpha. So what is the value of alpha? Nothing but 5 by 6. What is 5 by 6? 0.833. You are getting the value as 0.833. How was the question, my dear friend? How was the question? Yes. Tell me fast. You can't do any calculation mistake. Committing a calculation mistake is a blunder. My dear friend. Yes, you need to understand that. Committing a calculation mistake, knowing the concepts, is the blunder in the exam, which you can't commit. Whatever you know should be answered very properly, very clearly, in the proper time also, so that you can score maximum. So that you can only get if you can practice more and more with the test series. The more you write the test series, the better you are going to become day by day. Okay. So please don't miss the test series. Write the mock test more and more. We are here for you to practice more and more questions. This will be done in all the subjects, but make sure you are working hard with your concepts. This is the time only when you have to work hard, right? So coming to the next topic, obviously SFD and BMD is the part where we always say that the concept will be used somewhere or down the other, right? Maybe in deflection, maybe in structure analysis, somewhere they're going to use it. Okay. So the next topic is shear force and bending moment. So shall we start the question? Shall we start with the questions, my dear friend? Yes. Shall we start with the questions? Okay. So that's question number 4 for you all. Just read the question. Before reading the question, let's show the diagram. This is what? Simply supported beam subjected to UVL. This is a simply supported beam subjected to UVL, right? So shall we come to the questions now? Shall we come to the question now? Yes? Shall we come to the question now, my dear friend? So let's come to the question now. Let's come to the question. The MSQ. It's a MSQ. Please read the question very carefully, my dear friend. The question very carefully. The maximum intensity of the UVL is at the left support. The maximum intensity of UVL is at the left support. I've not given you timer, but I'm reducing the... Okay. Don't be in a hurry to answer me. You might have done this question before also. Might have done this question before also. A. It's a multiple select question. The multiple select question. And please check what you need to answer before answering me. B and C. B and C. Now, in such questions, my dear friend, like there is a question of MSQ, you have been given 2 marks and it will hardly take 1 minute. So, are such questions used to be asked in the GATE exam? Yes. There are certain questions we can ask which you can answer very quickly, right? But there are certain questions which will take more than 3 minutes in the exam. So what is the best way? The best way is save that time for the last. Don't give extra time at the start of any question. Okay? And obviously, let me tell you one thing. Whenever there are easy questions, the maximum error comes in those questions. So see here. If I look here, it is said a simply supported beam is subjected to UVL, right? Now what are the things that we can ask? Shear force, maximum bending moment, ratio of the slope. Now, you need to know everything about this. You need to know everything about this. And it has been asked which of the following are not correct or incorrect. It is not about correct, it is about incorrect, right? So now, if I look at the part, so we are very clear with this that the slope at A will be greater than slope at B because the point where the intensity is more, slope will be more. That's basic common logic here. Yes. So theta A by theta B will be greater than we don't need to find it. It is not required to find it. It is not required to find it. We don't have to find the value. But it is very clear with us. Yes, The slope will be more. Now, coming to the next. If I draw the shear force diagram, even that we have already done, and I've already mentioned that this is a standard case, if you all remember. So this is your shear force diagram with the value. Here it is WL by 3. Here it is WL by 6. So WL by 3, WL by 6. This is your 2 degree. This is your 2 degree with plus and minus. Yes or no? So this obtain at a distance of what? L by root 3 from the left support. L by root 3 from the left support. Yes? Yes? Is it correct? No. No. It is not L by root 3 from the end where the loading is maximum. No. It is what? From the point where base is there. Now, my dear friend, this value is how much? L minus L by root 3. So that is what? Root 3 minus 1 into L by root 3. Yes or no? Tell me, my dear friend. So you have been asked that it is 2L by root 3. So you understood that point. Next, coming to the bending moment diagram, you all know that the maximum bending moment value will be what? WL square divided by 9 root 3. This we all know. The degree is 3 degree. This is your bending moment diagram. Yes. Now, coming to this, the shear force is 0 at distance of 2L by root 3. The statement is wrong. The ratio of the support reaction A to B is 2. Yes. What is said? WL by 3 to WL by 6. है ना? WL by 3 to WL by 6. So it is true. The statement is correct. Maximum bending moment is what? WL square by 9 root 3. The ratio of the slope A and B is more than unity. Now, when I say more than unity, we don't have to consider the sign. When I say more than unity, I'm concerning about the magnitude. Okay, so the statement is correct. So which is wrong? You have to mark the incorrect ones. The answer will be A. Okay. Yes. Sir, SFD का स्लोप रॉन्ग है शायद. SFD का स्लोप अच्छा ये बता रहे हो. सही कर लो ना इसको. सही कर लो. Just correct it. This will be the value. This will be the diagram. This will be the diagram. Is it okay now? Is it okay now? Yes, this is your 2 degree. This is your 2 degree. Okay. Done? Done? Good. 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 So the answer is only A. Sir, it is a MSQ. Is it required that more than one option should be correct? Although it is a MSQ, yes? No, there is no compulsion. Right? Right? Okay. So let's move on. Let's move on. Are you ready for the next question? Yes? Have you enjoyed the questions till now? Have you enjoyed the questions till now? We have done 4 questions in a matter of 50 minutes. Have you learned something extra till now? In this 50 minutes, have you learned something extra till now from me? Yes? Obviously. Obviously, sir. I will be expecting that. I will be expecting that. Okay. So let's move to the next question. Please answer everyone. Please answer everyone. Should not take more than 2 minutes. Should not take more than 2 minutes. Sir, this is just a start of the questions. Tomorrow again I will be coming with the SOM with some more interesting questions, mind-blowing questions. You will be loving it. But that will not be on Gatewala English. It will be on Gatewala MEC and HC at 7 p.m. Sir, everyone. Being a question is being given, the equation for the deflection has been given to you. Length and m naught is given to you. You have been asked that what is the magnitude of shear force at the middle of the beam. Now, most of you might be having a question, sir. It is a case of uniform shear, that is uniform bending. Sir, the shear will be zero. Don't look in this way. The equation that has been given to you, that you according to that you need to answer. According to that you need to answer. The question that has been given to you, according to that you need to answer. The equation that has been given to you, according to that you have to answer. Don't look at the figure and say, sir, it's a case of the uniform bending moment. The shear is equal to zero. Nothing as such. You need to see the equation and accordingly you need to answer. 25 L square by 8. Okay, let's look now. I don't know why it has taken so long for you all. See, we all know some relation. What is the relation, sir? Y stands for? Y stands for deflection, right? Y stands for deflection. Dy by dx stands for slope. Dy by dx stands for slope. d2y upon dx2, right? Or we multiply with this with ei. This is equal to what? Bending moment. This is nothing but bending moment. Then further we write that as ei dqy upon dx3, third derivative. This is nothing but equal to shear force. This is nothing but equal to shear force. And ei fourth derivative, this is equal to load intensity with the minus sign. Yes, we have already covered this. Tell me yes or no, my dear friend. We have already covered this. Yes. Now, it has been told that the deflection equation, is m naught h cube minus h square L. Deflection equation m naught h cube minus h square L divided by 4 EIL. This is given to you. Tell me, my dear friend, this is given to you. Yes, this is given to you. Now, if I go for the dy by dx, I'm taking 1 by 4 EIL, m naught divided by 4 EIL outside. So this value will be what? 3h square minus 2HL. Next, if I go for d2y upon dx2, multiply this with EI. So I'm going to get as what? M naught divided by 4L into 6x. Then if further I go for the differentiation, so what I'm going to get? What I'm going to get? 6 by 4 into M naught by L. Yes, that means the shear is independent of the distance. This is going to be the shear force and it is independent of the distance, right? So M naught value is how much? M naught value is 100 Newton mm. M naught value is 100 Newton mm. 100 Newton mm. And the length is how much? The length is also 100 mm. So you are going to get the answer in Newton. Because Newton mm by mm cancel out. Aapka jo answer hoga, the answer that you are going to get will be in Newton. So 100 cancel out, the value will be 1.5 Newton. The value will be 1.5 Newton. Now you have to check in which unit you need to answer. You need to answer in Newton, my dear friend. So your answer will be 1.5. Your answer will be 1.5. How many of you committed mistake? Just in the differentiation part, you have committed the error. Most of you. 2HL. Where the 2HL gone? No. Put here 2HL, my dear friend. Put here 2L. Now further in the differentiation, it will be vanished. Manoj, in the further differentiation, it will be vanished. Is it clear? In the next differentiation, when you differentiate next time, it will be vanished. Is it clear to all? Is it clear to everyone? Tell me first. Tell me first. So the answer is 1.5 Newton. You have been told to write the value. You are getting the answer as 1.5. Very good. Reshav, Aditya, Akshay, Shivam, Bhupender, Rupali. Very good, my dear friend. You all have got the correct answers and keep continuing this. Good. Very good. Very good. So this was your question number 5. This was your question number 5. Understood? So till now, I've discussed 5 most probable topics that could come in the GATE exam. Coming for the next. Are you ready? Are you ready, my dear friend? Arre, tell me, Baba. Are you ready? So let's move to the next topic. That is again principal stress and maximum shear stress. Every year they ask the question either in the stress transformation or in the strain transformation part. They used to answer the questions on this. So let's see the question. Let's see the first question, my dear friend. Fast. I hope you will be answering it very clearly. I'm not a good English speaker, my dear friend. I'm just speaking. I'm just having a normal knowledge of English. And just that you need to have the confidence while you're speaking. You will be a good speaker. Okay, Harry? Answer, everyone. The answer? B is the answer. 30. That is B. Shubham. B. Very good. B. Good. Very good. Very good. Very simple question, right? Very simple question. Yes, it is. Just that you need to remember the formulas very properly. What is said? A point in the body is subjected to the plane state of stress in the XY plane. Sigma x is given to you, sigma y is given to you, and the major principal stress is given to you. What is the magnitude of in plane shear stress tau xy? So we all know, if it is the major principle, what we will write, sigma P1 is equal to sigma x plus sigma y by 2 plus root over sigma x minus sigma y by 2 whole square plus tau h square. Sir, in this type of question, you need to be very fast with your calculations so that you can save time for the other questions. Right? Now, so sigma P1 is given to you as 150. Sigma h is 140 plus 60 divided by 2 plus root over 140 minus 60 divided by 2 whole square plus tau xy whole square. Now, if I look here, 140 plus 60 by 2, this is 100. 150 minus 100 is 50. Root over 80 by 2, that is 40 square plus tau xy square. Sir, without any calculation, sir, without any calculation, my students can clearly answer this as 30 megapascal, yes or no? Because this is nothing but 3, 4, 5 rule. This is nothing but 3, 4, 5 rule. I always ask my student to remember few points like 1 by 3 plus 1 by 6 equal to 1 by 2. Right? 3, 4, 5. Right? You always remember this. They will be asking such questions. Already I proved it when I was solving the PYQ. Right? So the value is 30. The value is 30. Okay, the value is 30. So very simple question, my dear friend. Very simple question. And in such questions, the target should be saving of time. The target should be saving of time. Okay, Manoj. Good. Good. Now, what can be the next question? What can be the next question? The strain transformation and the principal strain. Manoj, there is nothing as different now. It is nothing different. The concepts are same now. Some concept can never be changed, whether it's mechanical or civil. So you can sit and answer. That's not a problem. So strain transformation and principal strain. Strain transformation and principal strain. Because the last time they asked with the stress transformation, so expecting that they will be asking from strain transformation. Right? Okay. Please answer everyone. Please answer everyone. Be careful while you are answering. Be careful while you are answering. Giving you minutes for this. Know the formula, you will be answering it faster. Don't know, it will. Inform your friends, those who are also attending always regularly. Please inform them about the class so that they don't miss the pre 24. Rishabh is saying 24 is the answer. Okay, let's see what others are saying. Told for finding the normal stress. It is not strain at 30 degree to the x direction. So make sure units are correct. Make sure you are writing all the data very properly. Last 15 seconds. Take is there. Please answer everyone. 67.52. Okay. $7.77. Let's see. Sir, it is said that it is subjected to tensile forces in X and Y direction. First, you should understand the question properly. Then only you can answer it. Then only you can answer it. Don't understand the questions, my dear friend, it will be trouble for you. It will be a trouble for you. Just see here, everyone. It said that a flat brass plate was stretched by the tensile force in X and Y direction. So let us write sigma X, sigma Y, sigma X, sigma Y. The strain gauge shows in the X direction, strain is 0.00072 and strain in Y direction is 0.00016. Yes or no? 0.00072 and 0.00016. This has been shown. What is said further? What is the correct normal stress on a plane inclined at 30 degree to the X direction? So let us say this is the plane at which I need to find the normal stress, and this is inclined at an angle of 30 degree. Very good, sir. Now, we need to understand this sigma X and sigma Y are principal stresses. How many of you understood this? How many of you understood this? That the sigma X and sigma Y are principal stresses. Yes? Understood this point? That means this epsilon X I can write as epsilon P1. This epsilon Y I can write as epsilon P2. Yes or no? Tell me yes or no. Tell me yes or no. Now, to find the value of normal stress on the inclined plane, first I need to find the value of sigma X and sigma Y. So we need to use the formula sigma P1. Sigma X is nothing but sigma P1. Sigma Y is nothing but sigma P2. So sigma P1 is equal to E upon 1 minus mu square into epsilon P1 plus mu times epsilon P2. Remember this formula, my dear friend? Remember this formula, everyone? Yes or no? So now, if I look at the part, 0.8 into 10 power 5 megapascal. Very good. 1 minus mu is 0.3. So we need to square it. Epsilon P1 is 0.00072. 0.00072 plus mu times, that is 0.3 into 0.00016. 0.00016. What is the value of sigma P1, everyone? What is the value of sigma P1? What is the value of sigma P1? Beta, there is no shear. If there is no shear, we'll write it as principal only. Achha. If there is no shear on the plane, we'll write it as a principal. Right? What is the value here? What value you're getting? 67.516 megapascal. 67.516 megapascal. Remember why I'm writing megapascal? Because I put the value of E in terms of megapascal. Right? I put the value of E in terms of megapascal. Now, so got the value of sigma P1. Coming to the value of sigma P2. So sigma P2 is what? E upon 1 minus mu square. Epsilon P2 plus mu times of epsilon P1. So the value of E is 0.8 into 10 to the power 5 divided by 1 minus 0.3 square into epsilon P2 is 0.00016 plus mu is 0.3 into 0.00072. What is the value that you are going to get? What is the value that you are going to get for the sigma P2? भैया अगर if it is principal stress, if it is a principal plane, तो obviously वो चाहे whether you take stress, whether you take strain, it will be same. 33.054. 33.054. 33.054 megapascal. 33.054 megapascal. Now, you got the value of sigma P1, you got the value of sigma P2, which will serve as sigma X and sigma Y now. My dear friend, we need to find on a plane at an angle of 30 degree. Now wait, we know we always find with respect to, what? Vertical. And this is clockwise. So theta will be what? Theta will be what? Minus 60 degree. Yes or no? Theta will be minus 60 degree. It is not plus 60 degree, my dear friend. So I hope you have not committed this mistake. Because here, see, it is given 30 degree with respect to X direction. So if it is given 30 degree with respect to that direction, we are going to take it as a positive value. And positive is what? When I take with respect to the horizontal, I take in the clockwise direction. That is anti-clockwise direction. That is the positive for us. Anti-clockwise is positive for us. That's why I've taken with respect to the horizontal in the anti-clockwise direction. Now, you got sigma P1, P2. So strain at an angle of this 60 degree minus, make sure you are remembering that. So epsilon h cos square minus 60 plus epsilon y sin square minus 60 plus, it's not epsilon, sigma n, sigma h, sigma y plus 2 tau hy cos of minus 60 into sine of minus 60. Although here, if you don't remember minus 60 part, that's not an issue. Although if you don't remember minus 60 part, not an issue, because tau hy has become equal to 0. Right? So sigma h is how much? Nothing but sigma P1, 67.516. 67.516 cos of minus 60 whole square plus sigma y is 33.054 sine of minus 60 whole square. What is the value, my dear friend? Please tell me fast. What is the value of the normal stress? What is the value of normal stress? What value you are getting for the normal stress? What value you are getting for the normal stress? 41.67. What others are getting? Same. Okay. So understood where you all are committing the mistakes, my dear friend? Understood where you all are committing the mistakes? Tell me yes or no. Understood where you all are committing the mistakes? Tell me, da Baba. Yes. So what is the answer? Now one more thing. Should you write the answer in 41.67? Should you write the answer in 41.67? You got the answer as 41.67. But should this be your final answer? Should this be your final answer? Tell me yes or no. Should this be your final answer? No. It has been clearly asked. You need to answer in nearest integer. There should not be decimal. So the value is 42. Your answer is 42. I hope you know how to do the round off. If it is 41.5, if it is 41.5 and you need to round, what will be the value? If it is 41.5, what will be the value? I'm going to round off in the nearest integer. The value will be 42. Any value above this, like 41.6, it will be 42. If the value is less than 5, the value will be previous one. Is it clear to everyone? Tell me fast. Rounding off should not be an error from your side. Last to last year, so many students have committed errors in this part. And you might have seen that the gate doesn't give you that extra buffer space for the answers. Right? So I always say, try to be exact as much as possible. Okay. Is it clear to everyone? Is it clear to everyone? So this was your question number 6 or 7. Might be. Okay. I think this was question number 7. Good. Right. Shall we move to the next question, my dear friend? 7 questions, over 50% we have completed. Almost. So the next is bending in composite section. You all have learned about the flinch beam? Yes or no? You all have learned about the flinch beam, right? We have already discussed in detail about the flinch beam, right? Composite section, bending in composite section. So based on that, this is a question. Please try to solve, everyone. The MCQ for 2 marks. Please try to get the answer. It's MCQ for 2 marks. Please try to get the answer, everyone. Question number 8, regarding the bending in the composite section. I've been asked the moment of resistance. You know the basics, very easy. It will be cakewalk for you. Don't know, it will be very difficult. Please solve, everyone. Now, this is the time when I will be seeing your determination that for how long you can sit. This is the time when it decides that how long you can sit. 3 hours sitting habit need to be there with you all. 3 hours sitting habit need to be there with you all. And that's why I'm planning the sessions of 3 hours. No answers till now. Bad. Too bad. Composite section is made up of solid rod of steel 20 mm diameter surrounded by the bronze cylinder of 30 mm external diameter. The allowable stress in the bronze and steel are 100 megapascal and 150 megapascal respectively. The moment of resistance of the section if E steel is equal to 1.218 times of E brass. Sir, this can I solve this question without using concept of modular ratio? Can I get the answer without using concept of modular ratio? Tell me yes or no. Tell me yes or no. Yes, obviously we can. Obviously we can. If I look at the system, if I look at the cross section, my dear friend, if I look at the cross section, it can be clearly seen, it can be clearly seen that the inside part is steel. This is solid. So this is your steel. And the outside part is bronze. The outside part is bronze. It is said that for the solid part, my dear friend, the diameter is 20 mm, right? And if we look at the hollow part, that is the outside which is made up of the brass, this is of the diameter that is 30 mm. So it is very clear, my dear friend, that the steel is solid and the brass is hollow, right? Clear? Now, so we talk about the moment of resistance. The moment of resistance will be the combination of brass as well as steel. Moment of resistance will be a combination of brass as well as steel. Yes or no? We know that this is nothing but sigma max brass multiplied with section modulus of brass. Yes or no? Multiplied with Z brass plus sigma max steel into Z steel. Tell me yes or no, my dear friend. Tell me yes or no. The first part, is this part clear to all? Is this part clear to everyone? Yes? Is this part clear to everyone? So if it is cleared, moment of resistance will be equal to sigma max brass, or that's bronze, right? It's a bronze rather than brass, it is bronze. Bronze plus moment of resistance steel. So for the bronze it is hollow. For the bronze it is given as how much? 100. For the bronze it is given as 100 megapascal. Multiply with. You need to find the section modulus for the bronze. That is how much? Pi by 64 into 30 ka power 4 minus 20 ka power 4 divided by what? 30 by 2. Yes or no? Plus, if I find the moment of resistance for steel, it will be what? Sigma max steel is 150. 150 into I steel, that is how much? Pi by 64 into 20 ka power 4 divided by 20 by 2. So this answer you are going to get in Newton mm. Right? You have been told to answer in which unit? You have been told to answer in Newton meter. So divide by 10 ka power 3. You will get the answer in Newton meter. What is the answer, my dear friend? What is the answer you are getting? What is the answer? Rishabh is saying B, sir. Rishabh is saying B. What others are getting, sir? 330.52. What others are getting? Please answer, everyone. What others are getting? What value you are getting, my dear friend? What value you are getting? 330.52. Rishabh is saying. What others are saying? So till now you are dealing with the rectangular cross section. That was very easy for you all. Now we have changed the question with the circular. It doesn't have any effect, my dear friend. It doesn't have any effect. If you know the concept, it should not hamper your solving technique, right? Something different you obtain, something different you got in this particular question, yes or no? If till now, till question number 8, I think this is question number 8. Yes. So if till now everything is crystal clear, I need to see only heart symbol in the chat section. If till now everything is cleared, crystal clear, and you have learned something new, I want to see only heart symbol in the chat section. Yes. Good, 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 good. Everything is clear, my dear friend. Everything is crystal clear. You are learning new concepts. You are learning new concepts, not about the concept in terms of like you are getting some knowledge, but in terms of like you are learning how to practice or how to solve question, how to apply your brain in a question, in a new question that you are going to get. Right? Okay. So the next part that can be asked is shear stress and shear flow. They can ask from shear stress and shear flow. Okay. So let's see the question, everyone. Let's see the question. Please answer this. It's a MSQ 2 marks. It's a MSQ 2 marks. Wait. MSQ 2 marks. Question number 9. Question number 9. Please solve. Tuck. Okay. Please solve, everyone. I'm seeing the time. It's 5:33. We'll take at 5:36. The multiple thread question, more than one answer can be correct. Please go through that in a proper way. Rishabh is saying D is the answer. The multiple choice question. Multiple choice question, Rishabh. So please check once before answering. Check once before answering. Giving you 30 more seconds. Please try to answer. Okay. Shall I answer now? Shall I answer now? Is the question tough? Now you tell me, is this question tough? You have learned so many concepts, my dear friend. Ask your heart and tell me, is this question tough for you? Is this question? Ask your heart, है ना? And tell me, is this question tough? I want to see your answers in the chat section. I want to see your comment in the chat section and tell me, is this question tough that you are not able to answer in 30 or 3 minutes or 4 minutes? You are not able to answer. Is it something like that? No. Where we lag? Speed. Okay. So, let's see first. What is said? The moment of inertia of a T section is given to you. Okay. 0.012 meter per 4. Okay. The flange of the beam is 0.3 meter wide and 0.1 meter deep. It's a T section. So let us first draw the T section first. Let us first draw the T section first. So this is the flange part and this is your web part. Okay. So now what the data is saying? Moment of inertia is 0.012 meter per 4. Moment of inertia is 0.012 meter per 4. So obviously we will convert in the mm per 4. So 0.012 into 10 ka power 12. That is nothing but 12 into 10 ka power 9 mm ka power 4. Right. Okay. Next. The flange width is 0.3 meter. So that is nothing but 300 mm. Flange is 300 mm. And depth is 0.1 meter. That is nothing but your 100 mm. Next, what is said? It is said that, and the web is 0.1 meter wide. The web is 0.1 meter wide. That is nothing but this is your 100 mm. Next, the neutral axis of the beam is 0.25 meter below the bottom edge of the flange. 0.25 meter, that is nothing but 250 mm. So let us say this is your neutral axis. This is your neutral axis. It is at a depth of 250 mm. It is, till now it has not mentioned the depth of the entire cross section or the web. So let's not focus on that. The shear force on the section is 720 kilonewton. Shear force on the section is 720 kilonewton. Now what has been asked? The ratio of shear stress in the flange to web. The ratio of the shear stress in the flange to web at the junction is 3. Ratio of the shear stress, sir. Flange to web, where there is a junction. So let us say this point is A. Right? This point is A. So we all know the area will be same, y bar will be same, everything will be same. The only one difference is the width. The only one difference is width. So tau A flange, yeah, tau is inversely proportional to width. Yes or no? So tau A flange upon tau A web will be nothing but width of web divided by width of flange? Tell me, my dear friend. Yes or no? So width of web is how much? 100. Width of flange is 300. So the value is 1 by 3. So just need to check it is flange to web or web to flange. The ratio of shear stress in the flange to web. The ratio of shear stress in flange to web. Now you tell me it is 1 by 3 or 3? It is 1 by 3 or 3? The neutral axis of the beam is 0.25 meter below from the bottom edge of the flange. Is from bottom edge, it will be 350 mm, right? This will be 350 mm, right? The value will be 350 mm. From the top, if I am taking, is 350 mm. So the value is 1 by 3. So the value is 1 by 3. So if I go for the flange to web, the value is 1 by 3. So the first statement is right or wrong? So the first statement is right or wrong? Tell me, my dear friend. The first statement right or wrong? It is wrong. The first statement is wrong. It has been mentioned as 3, but it should be 1 by 3. The first statement goes wrong. Next. The maximum shear stress in the flange is 1.5 megapascal. Where will be the maximum shear stress, my dear friend? Where will be the maximum shear stress? Where will be the maximum shear stress? At the neutral axis, we'll assume this only. We'll assume this only, that the maximum shear stress will be at the neutral axis, like this. Somewhat like this. Yes or no? Somewhat like this. This is your diagram. This is your diagram. Now, before finding tau max, the kink of the shear stress will be observed at the junction. There is a sudden change. Kink means change in the shear stress is observed at the junction. Is it correct? Is it correct? Is it correct? Tell me first. First, tell me this value. The kink is observed at the junction. Is it correct? Yes? Obviously, I can see that there is a kink. Okay, the statement is correct. D is correct. Now, again coming to the point, 250 wala part. What is said? What is said? Listen again. What is said? According to the question I'm going, the neutral axis of the beam is 0.25 meter from the bottom edge of the flange. It said the bottom edge. Sir, if I look at the flange part, this is your top edge. This is your bottom edge. Yes or no? Tell me first. Bottom edge and top edge. Manoj, tell me beta. Bottom edge and top edge. Top edge is which one? There is a T section. There is a T section. There is no thickness, right? There is no thickness that you can differentiate from the top or bottom. Okay. So this is your top edge, and the below it will be the bottom edge. Right? So you have to take the distance from the bottom edge. So this value is how much? This value is how much? 250 plus 100 will be 300. Is it clear now? Is it clear, Manoj? Is the point clear? Now, so the next part of the discussion is it 3 degree? Is the variation 3 degree? Tell me, my dear friend. Is the variation 3 degree? No, it will be 2 degree. It will be 2 degree. So C is also wrong. It will be 2 degree. So C is also wrong. Coming to the next, that is maximum shear stress in the cross section. So tau max will be at neutral axis. That is nothing but VA y bar divided by IB. Yes, have you find this value? Have you find this value, my dear friend? See, we can take two areas. This is one area. This is another area. I can write A y bar directly. I can write A y bar directly. Flange में पूछा है. Maximum shear. Okay. It's very easy then, na? It's very easy then. Not even requiring the concept of neutral axis. Tau max flange will be at the bottom part of the flange. Yes or no? This is very easy then. It should not take much time. IB. What is shear force? Shear force is 720 kilonewton. So converting the Newton into 10 power 3, area is how much? 300 into 100. अच्छा y bar यहाँ पे चाहिए आपको. This is 250 plus 50. That is nothing but 300 divided by I is given to you. What is value of I? 0.012 meter power 4. That is 12 into 10 power 9. 12 into 10 power 9 mm power 4. And what is the width? Since I'm talking the flange, it will be how much? 300. Get the value. You get the answer in megapascal. You get the answer in megapascal. You can cut whatever you don't want. So this is 4, 6, 8, 10. Right? This is 10. So I can cut this one. Very good. 12 3 ja 36. 2 ja 72. What value you are getting? 3 2 ja 6. 3 ja 18 megapascal. Are you getting this value, my dear friend? Are you getting the value as 18 megapascal? Is it 18 megapascal? 1.8. Is it 1.8? Okay, this 10 is here. 1.8 megapascal. 10 is there. 1.8 megapascal. The value is 1.8 megapascal. And it is written as 1.5. So this goes wrong. So what is the correct answer? The correct answer is only one. That is D. Your correct answer is only one. That is D. Yes? Are your concepts getting revised, my dear friend? Are your concepts getting revised? Yes? With this particular questions, can you understand that you need to practice more? With this particular questions, can you understand that you need to practice more and more? Right? Sir, last 20 days. For you, there is 30 days. Right? Push your limit. Give more than 100%. Let the destiny decide where you have to go. But you can't lose your efforts. You can't just give up to your destiny, that leave everything to the destiny. Unless you put effort, you will never expect, you can never expect that you will get the result. So push hard as much as you can in this last 30. Civil engineering student, I'm telling you again and again. This last 30 days matters a lot. The effort that you are going to put right now will be considered. Get your result. Right. I hope you understand. Namaste, Vineet. Namaste. Right. Okay. So let's move to the next question. Hinge questions. Each year I see a question on the hinge, either in the SOM, either in the structure. They ask a question on this. So let's move to this question. Let's see what this question asks from you all. That is question number 10. It should not take much time. Again, it's a MSQ of 2 marks. So be accurate with your answers. Be accurate with your answers. Okay. It's 549. We'll take at 552. Please see the question first. Vineet, please guide. Vineet is always there to guide. Beam is shown in the figure below. E is given, I is given. You need to choose the correct statement. Support reaction at B, deflection at D, design bending moment for the beam. 2 marks. The class come. It has just, I think it will be over by 7 p.m. So we'll get in touch at that time. Class will be over by 7 p.m. So we'll get in touch after that time. Okay. Call me just after that. is given, I is given. To know the concept of the hinge for answering this question. Know the concept of hinge for answering this question. Last 1 minute. Last 1 minute. Not that difficult that you're facing such a problem. Very easy question. Very easy question. ABC. ABC. Okay. So ABC. Rishabh is also saying electro pianist. My God. ABC. Okay. So two answers are there. ABC. ABC. Three. Aditya is also saying. Shivam is also saying. Good. Good. Very good. So let's see. Are you ready to see the answer, sir? Are you ready to see the answer in the quickest time? That is important. Yes. Sir, AC is correct, but doubt in deflection. Okay. Let's see the answer, sir. Let's see the answer. Sir, we already discussed these questions so much. Yes. If you have done my classes, you all know that we have done this type of questions a lot. Yes or no? Obviously, sir. Just look here. Just look here. This is a beam. Okay. Here there is a simply support. And here it is a hinge. We all know it is a determinate structure. Directly without using any structure concepts, we can find the values. So 4 meter, 3 meter, 1 meter and 10 kilonewton. So 4 meter, 3 meter, 1 meter, 10 kilonewton. This is given to you. Okay. What are the points? A, D, C, B. A, D, C, B. So before finding the answer, we can clearly see that if I draw the free body diagram, I can separate before hinge and after hinge. Yes or no? I can separate before hinge and after hinge. If this is 10 kilonewton, this is 3 meter and 1 meter. I can write this as PB by L and PA by L. Tell me yes or no. I can write this as PB by L and PA by L. Yes or no, my dear friend? So the value is 2.5 and 7.5 kilonewton. The value is 2.5 kilonewton and 7.5 kilonewton. Right? The same load will be applied here. The same load will be applied here. This is how much? 2.5 kilonewton. Yes or no? The length is how much? 4 meter. This is A. This is D, E, C, B. Right? Right? So now, my dear friend, what is the first statement? The support reaction at B is 7.5 kilonewton. Is the first statement correct? Is the first statement correct? Tell me yes or no. Is the first statement correct? The reaction at B is 7.5 kilonewton. The reaction at B is 7.5 kilonewton. Yes or no? The first statement is correct. Yes, the statement is correct. Now the next point is deflection at D. So if I look just on the on the left portion, can I say that deflection at D can be given by a formula? Arre, tell me, re Baba. Deflection at D is nothing but PL cube divided by 3 EI. Tell me yes or no. Deflection at D is nothing but PL cube divided by 3 EI. So the load is 2.5 kilonewton. Convert in the Newton. Just check the value of E and I. Okay, Newton, very good. So converting the Newton, length is 4 meters. So 4 into 10 over 3 whole cube divided by 3 E. What is the value of E? 2 into 10 power 5 Newton per mm square. 2 into 10 power 5 Newton per mm square. And what is the value of I? 10 power 8 mm power 4. 10 power 8 mm power 4. So solve this, you are going to get in mm. What is the value in mm, my dear friend? What is the value in mm? What is the value in mm? What value you are getting in mm, my dear friend? Tell me fast. This value will be 10 power 9, 10 power 12. You can see that there is some cancellation. So I can see that here 2.5 into 6.4. Okay. This is 64 into 10 ka power 12 divided by 6 into 10 ka power 13. So this will be cancelled out. This will be 10. 64 by 60 into 2.5. In any means, it can't be 5.67. But you need to get the value. What is the value? 2.67. 2.67 mm. So this is also correct. This is also correct. Very good. This is also correct. Obviously, if B is correct, then D will be wrong. If B is correct, then D will be wrong. Yes? Yes. Now the next is a design bending moment. So you can draw the bending moment diagram separately and get the value. You can draw the bending moment diagram separately and get the value. Yes, because at D the bending moment will be 0. If I look here, the bending moment value will be what? 2.5 into 4. That is nothing but 10 kilonewton meter. Right. If I see here, I need to find the bending moment at C, which is nothing but 7.5 into 1, which is nothing but 7.5 kilonewton meter. That's it. These are the critical points, right? At A, B, C, D, these are the 4 critical points. Yes or no? Tell me, my dear friend. Tell me, my dear friend, the bending moment at A is how much? Minus 10. If I draw the diagram, this is minus 10. Then till D, it will go linear, it will go up till the point 7.5, and then it will go down. This is your bending moment diagram. Yes or no? Tell me, my dear friend. Tell me, my dear friend, are you getting this value only for the bending moment diagram? Are you getting this value only for the bending moment diagram? So the design bending moment will be what? Design bending moment will be where always we talk in terms of magnitude, maximum value. So that is 10 kilonewton meter. That is 10 kilonewton meter. So the answer will be C. So A, B, C. A, B, C. Most of the students answered it correctly. Very good. The answer is A, B, and C. The answer is A, B, and C. Enjoyed the question? Enjoyed the question, my dear friend? Sir, maximum bending moment diagram and design bending moment diagram same. See, it's not bending moment diagram, it's bending moment, my dear friend. When it's a maximum bending moment, we talk about it can be local maximum, it can be local minima. That's not the point. The point is, if it's asking design, then we need to talk in terms of magnitude. Okay, so in that case, we see all the maximum values. Got the point? Even it just asks maximum bending moment in the question, you need to, if suppose there are 3 to 4 points which are having the maximum bending moment point, that is the local maxima minima, you need to check you need to take the maximum value, right? No, if it is related to the field, if it is asking I apply this load work, this is what these are what, if you are applying this load, these are the working loading, right? And if you need to take the factor of safety, then you will be given with the material, you will be given the factor of safety, then you need to apply that. Okay, got the point? Electro pianist, is it clear? Okay, let's move to the next topic, that is deflection in non-prismatic structure. Deflection in non-prismatic. Have you seen so many questions on this topic? Have you seen many questions on this topic? Tell me yes or no. Have you seen so many questions on this topic, my dear friend? Yes? If you see the last 10 years, you have seen so many questions on this, right? So we need to understand this and we need to solve this. And a deflection question. Question number 11, please answer everyone. Please answer everyone. It's you who have to decide which method you want to follow. No compulsion. Follow whatever you want. Follow whatever you want. So you have always seen my Hindi English version. Have you enjoyed this English version of me? You have already always seen my English version where I teach in Hindi plus English and write in English. But this is pure English version of me. So I would be requiring a feedback because those who know me earlier, they even know that I already took the English classes on the YouTube also, right? Please solve. Please solve everyone. Get the value everyone. One is deformable, other is rigid. The deflection under the load. The deflection under the load. The slope at B. Two things that you need to find. Two things that you need to find. Which method you are preferring? Just tell me. Slope at B, it is not slope at A. Make sure you understand that. C and D. C and D. Bhupender is saying C and D. What others are saying? What others are saying? C and D. Rupali is also saying C and D. Rishabh is also saying good, good, good. Very good. Very good. C and D. Good, good, good. Very good. So let's see the question. Let's see the question now. A simply supported beam is constructed by welding a rigid beam to a deformable one. As shown in the figure, choose the correct statement. So, sir, if I draw the figure here, if I draw the deflected shape, here, it will be bent till here and then it will be a straight line, yes or no? Then it will be a straight line, yes or no? Tell me, my dear friend. It will be bent till A to C. It will be bent till it. The slope is not 0 at C, sir. The slope is not 0 at C. I cannot say that the slope is 0 at C. I will not say that. Okay. But what I am assured, this is the kind of deflected shape that I am going to obtain. Agreed? Now, either you can use strain energy, either you can use moment area method, Either you can use slope deflection method for finding the deflection. It's up to you. There is no restriction. There is no restriction. I will go with the strain energy. Why? See, if I know this deflection, I can find the value of theta, yes or no. Theta is nothing but delta by L. Yes. Theta is nothing but delta by L. Is this clear to everyone? If I talk about the slope at B, it is nothing but delta by L because it is rigid. Because it is rigid. Agreed, everyone? So I just need to find the value of delta. That means I just need to value of, I can apply the strain energy. Already the point load is there. There is no concept of pseudo load. So the loading are P by 2, P by 2. This side EI is there. This side EI is infinity. Right? This side EI is infinity. So now, my dear friend, if I take the section H1, H1, this is H. So the deflection will be observed only due to portion AC. For the BC portion, it will be equal to 0 because EI is infinite. Something by infinite is equal to 0. Let us do that. Let us do that. Let me show that also. Let me show that also. Just see here. Just see here. So moment at section H1, H1 is nothing but P by 2 into H. Del mH by del P, nothing but H by 2. Right? So U, that is, if I write delta at center, that is C, due to portion AC, will be what? Integral mH into del mH by del P into dH upon EI. Right? So the value will be what? P by 2 into H by 2 into dH whole divided by EI. Limit from, what is the limit? 0 to L. Limit is from 0 to L. So I put the value, I can take P by 4 EI. Integral H square is nothing but H cube by 3. Limit from 0 to L. So the value will be what? PL cube divided by 12 EI. PL cube divided by 12. Now, I always prefer strain energy over the other cases. Why? This will give you exact result. Now, if a situation arises where the strain energy will be very complicated, then you go with the moment area or the Castigliano's theorem. Is it clear to everyone? Is it clear to everyone? If the moment arises, if you use the strain energy, it will be very complicated. Then you go with the moment area or the Castigliano. Otherwise, prefer strain energy. Is it clear? I always prefer strain energy. It will always give me error-free results. Okay. So delta C AC is I obtain. If I go for the moment at the section H2, H2, this is again equal to P by 2 into H. So del mH by del P is nothing but equal to H by 2. Delta C due to portion CD, yeah, CB, is what? Something by EI, into some variable of H. Okay. Integrate. This EI is infinite, so the value will be equal to 0. Got the point, everyone? So the value will be equal to 0. So delta C is nothing but equal to PL cube divided by 12 EI. This is the value of delta C. Now, what is the value of theta C? That is theta B. Theta B is nothing but delta C divided by L. That is nothing but PL square by 12 EI. Is the point clear to everyone? Tell me, my dear friend, is the point clear to everyone? So the answer is C and D. Most of you got it correct. Most of you got it correct. Very good. Are you seeing different questions than what you have obtained earlier? Are you seeing different questions than what you have obtained earlier, what you have done earlier? Are you able to point, sir, yes, in this 2 hours, 10 minutes or 11 minutes, we have learned something, we have learned new questions We have learned how to approach new questions and make our mind very clear that whether it is any of the question, the concepts will remain same. The concepts will remain same. Yes. Tell me, Re Baba. Yes. Okay. 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 Let's see the next question, my dear friend. So the next question, the torsion in the composite shaft. The another important topic will be torsion in the composite shaft. So let's see the question on this. Let's see the question on this. Please answer everyone. Please answer everyone. Okay, get the answer. Get the answer. It's a MCQ 2 marks. Figure shows a composite shaft consisting of the steel surrounded by the brass. A torque of 600 Newton meter is applied to the shaft and it will be shared equally. Rigid modulus for the steel and the brass is given. What is the angle of twist? The length of the shaft is 6 meters. Length of the shaft is there. Answer everyone. I told you this is just the start for the question series. Tomorrow we'll meet again at 7 p.m. with SOM plus structure question where me along with Anirudh sir will be taking the session. I will be dealing with the SOM, Anirudh sir will be taking the structure part. So again, there you are going to see very good questions, sir. Roughly there we are going to solve around 30 questions. So yes, you understood that it will take more than 6 hours tomorrow. So make sure from 7 to 1 or 2 p.m. you are not giving any time anywhere. If you have planned anything for the evening, do it in the morning itself. Planned any revision in the morning part, do it in the evening part, do it in the morning itself. Any test you need to write, that should be written between 9 to 12 or 2 to 5, depending what is the time of your exam. Whether you are given the forenoon slot or you get the afternoon slot. The afternoon or your morning. Based on that, you need to plan. Very easy question. The parallel section, re baba. It's a parallel section. You have been given with that torque is divided equally. Already mentioned. C. Rupali Singh C. Rupali Singh C. That is 2 degree. Rupali saying 2 degree. Shivam is also saying C. 2 degree. Yes. Two degree. Let's see. Sir, this is a very simple question. It's a very simple question, sir. Right? It said that torque is applied, that is 600 Newton meter, shared equally. That means torque in steel is equal to how much? 300 Newton meter. And torque in brass, this is also equal to what? 300 Newton meter. Yes or no? Obviously, sir. Now, what is said? rigidity modulus for the steel is given. Rigidity modulus मतलब क्या? What is given? G, and for the brass is also given. What is the angle of twist? So either you can take brass or you can take steel. Yes or no? If you are smart enough, which you will be taking? If you are smart enough, which you will be taking, my dear friend? Theta. I will take steel. Yes or no? Because it is solid, calculation will be simpler. So TL upon GIP. Yes, I will take steel. So T steel is how much? 300 Newton meter. So multiply with 10 power 3. What is the length of steel, my dear friend? The length of the steel is 6 meter. So 6 into 10 power 3 mm divided by G steel. What is G steel? 8.4 into 10 power 4. 8.4 into 10 ka power 4. Now it is circular. So pi by 32. Make sure you are writing IP. So pi by 32 into 50 ka power 4. So this answer you are going to get in radian. This answer you are going to get in radian. I will be converting in terms of degree because it has been asked in terms of degree. So what I'm going to do, I'm going to multiply with 180 by pi. Yes or no? Yes or no? What answer you are getting, my dear friend? What answer you are getting? Please tell me. What answer you are getting? Solve it, everyone. Get the value. Solve it, everyone. Get the value. 2 degree. Okay. Getting the answer as 2 degree. Very simple, sir. Very simple. 2 marks. It's a gift to you. And such gifts used to be given by the gate people so that you can qualify in the exam. These gifts are given in the gate paper so that you can qualify in the exam. Is it clear? Is it clear? It's based on the parallel concept. The shafts are in parallel. We know the twist in both the shafts are same, right? So you can take any one. Already it has given that the whatever torque you are applying is been shared equally by both, right? So that is the biggest point that you need to take care of. Okay, the next part. The next part, thin cylinder and sphere. The next part, thin cylinder and sphere. Last year, last year. No, last year itself. They've asked the question on this. You remember? 15 and 7.5 wala question. Already we have done. Please answer fast. Please answer fast, everyone. Please answer fast. Cast iron, 1.25 meter in diameter, withstand 100 meter head of the water. Assuming limiting tensile stress as 20 megapascal, what should be the thickness of metal? Limiting tensile means what? For which it is saying? For which part it is saying? You have been given with the pressure. You need to apply the fluid concept. Height is given as 100 meter head of the water. Just 1 marks. Answer, everyone. A 13 cast iron pipe is 1.25 meter in diameter and is required to withstand 100 meter head of the water. Assuming limiting tensile stress of the pipe material as 20 megapascal, what is the thickness of metal in mm up to 1 decimal place? Last 1 minute. Last 1 minute. Last iron. Pipe 1.25 meter in diameter. 100-meter head lena hai. It has to withstand 100-meter head of the water. The limiting tensile. We should know that what is the major principal stress when it comes to cylinder. Because obviously has to withstand a cylindrical load. What should be the thickness of metal? What should be the thickness of metal? Shall I discuss then? Shall I discuss then? See here. We know that the hoop stress is the major principal stress. Yes or no? Maximum tensile stress. And this is given as 20 megapascal. And the hoop stress is given as PD by 2T. Yes or no? Yes. So 20 pressure we can write as what? Rho GH into diameter divided by 2T. Put everything in the proper units, you get all the answer. Rho is what? It has to resist water, right? So we will write as what? 1000 kg per meter cube. Let us say 1000 kg per meter cube. Multiply with 9.81. So you will get this in Newton. Right? You will get this in Newton. What is the head that it need to resist? 100 meter. 100 meter. So multiply with 10 to the power 3 to get in mm. Into diameter, that is 1.25 meter. 1.25. Again multiply with 10 to the power 3. Divided by 2t. 2 into t. What is the value of thickness, my dear friend? What is the value of thickness? What is the value of thickness? In mm up to 1 decimal place. In mm up to 1 decimal place. In mm up to 1 decimal place. I think some data is wrong. Is it? Is it some data is wrong? Just check. Just check if some data is wrong. What value you are getting? Because I think this is very big value that you are going to get from here. 20 megapascal, that is Newton per mm square. Yes, very big answer you will be getting. Some error is there in the data itself. In the data itself. The data itself, some error is there. 1.25 meter, 100 meter head of the water. Thickness is coming to be too large, I think. Thickness must be coming too large, right? Must be coming too large. So what we can do here? What we can do here? Newton per meter square, Newton per meter cube into, correct? The value, wait. This value is what? This value is what? If I see this value, this is Newton per meter cube, right? Right? This value is Newton per meter cube. Okay, just a minute. Just a minute, my dear friend. If I multiply this with, 100, that is the head. And if I multiply this with 1.25, so this will be meter square. Okay, this will be meter square. So still you are getting in terms of Newton per meter. So I will multiply this with 10 to the power 3. I will get in mm. Now get the value of t. Now get the value of t, my dear friend. Here, this is Newton per meter cube. This is meter square. So get Newton per meter. So if I convert as Newton per mm, multiply this with 10 to the power 3. Now you get the value. Now you get the value, everyone. Yes, what is the value you are getting now? What is the value you are getting now? What value you are getting, my dear friends? See here. 1000 cancel out. 1000 cancel out. Okay. 20 cancel out 100 by 5. Okay. 20 cancel out 100 by 5. Now you get the value of thickness. 15.3. Are you getting the thickness as 15.3? Yes. Gautam is saying 15.3. Beta, it is said thickness of the metal. It is said thickness of the metal. How can it be megapascal? How can it be in megapascal? Please check everyone again. What is the value you are getting? What is the value you are getting? Well, see the thickness. It will be what? It will be what? 30.656. 30.656. 30.656 mm. So you have been told to answering one decimal. So it will be what? 30.7 mm. The value will be what? 30.7 mm. Tell me yes or no. The value will be 30.7 mm. This is your answer. Okay. This is your answer. That is 30.765. Although you are getting 656. So if you convert, if you round up to one decimal, the value will be 30.7. Are you getting this value, my dear friend? Are you getting this value? Everyone getting the same value? Yes. Everyone getting the same value? Tell me, everyone. Everyone getting the same value? Good. Good. There is no approximation, nothing. Again, take care of the units properly. If by chance you see some very big answer, do check it again with the units. That's what I did just now. Okay. Is it clear? Is it clear to all? Shall we move to the next question? Shall we move to the next question? Yes. That was your question number 13. That was your question number 13. The next topic is column spring combination. How many of you fear when the spring comes? Sir, 0.62 or 0.63, then it will be 0.6, not 7. 0.6. The next thing is column spring combination. How many of you fear with the spring questions? How many of you fear with the spring questions? Sir, spring. How many of you fear with that? Huh? Spring. Sir, spring question has come. Bharatiya warriors do not fear. Very good. Let's see the question. Sir. Small amount, sir. Small amount fear we are getting. Nothing as such. Don't worry. It's very easy. Very easy. You should just know the concept of this. Nothing more than that. Just know the concept of this. Right? Just know the concept of this. So, try to answer everyone first. Then I will answer. I'm giving you 2 minutes to answer this. I'm giving you 2 minutes to answer this. Please try to answer. Then I will answer. Sumit, electrical class will also run on English Wallah. Don't worry. Sumit, electrical class will also run on English Wallah channel. Don't worry. As you have seen yesterday, mechanical class by Negi sir has been started, right? So already CS class is going on. So I took the first class for civil, right? Already the class was there. By, I think digital class was there for the electrical students by Chandan Jha sir on 10th. So don't worry about that. Everything is going, right? Okay. So our information king is here. Kuldeep sir. Right. Okay. Please see this question. Question number 14. A rigid bar AB of length L is supported by two springs of stiffness coefficient K1 and K2 and torsional spring stiffness coefficient KT as shown in figure. What should be the critical load for the bar AB? What should be the critical load for the bar AB? Yes. A. You are getting the value as A. A. It's all about free body diagram. It's all about free body diagram, sir. Nothing more than that. It's all about free body diagram. You want to see the free body diagram? I got one answer. That is A. What others are saying? What others are saying? Okay. Let's see the concept behind this. Let's see the concept behind this. Please, everyone, see here. Please, everyone, see here. So, there is a spring, right? There is a torsional stiffness here. Right? Again, there is a spring attached here. And I've applied the load that should be go to the bar AB, or this case as a column. Now, you need to find the value of P. You need to find the value of this P, right? Just see here. We just need to see the deflected shape, my dear friend. Let us say this is the deflected shape, that is theta. Okay. Now, the load will point here, P. This is delta. Also, my dear friend, one side the spring is going to get compressed. One side the spring is going to compressed. So let us say this is P1. Other side also the spring is going to be elongated, right? But the deflection is same for both the spring. So P1 will be what? Since the stiffness are different, K1 and K2. So this is K1. This side it is K2. So K1 into delta. This is your K2 into delta. Yes or no? Tell me, re Baba, yes or no? Yes. Yes. And a moment will be coming at A. Moment will be coming at A. Which direction? In this particular direction. The moment will be coming at A in the opposite direction, my dear friend. And that is what? Nothing but torsional stiffness has been given to you as KT. So that is nothing but KT into theta. Till this point, anyone having any doubt? Till this point, anyone having any doubt? Till this point, anyone having any doubt? If you understood this, then it's a game of free body diagram. If you understood this, this is a game of free body diagram now. Have you understood this? Tell me, my dear friend. Yes? Now, we are going to use the concept of equilibrium, because till before failure, your body will be in equilibrium, right? While we use the concept of equilibrium, let us take summation moment about A is equal to 0, clockwise positive, anti-clockwise negative. So what you are going to see? P1 into L, that is in the anti-clockwise direction, minus P2 into L, right? Minus P2 into L, minus P into delta must be equal to moment into theta. Tell me. Yes? Yes? Okay. Now one more part. This you are going to observe in which part? In the spring. So for the, if I just draw the free body diagram, just wait. If I just draw the free body diagram for what? For beam. If I just draw the free body diagram for beam. So since it is compression, so each force has equal and opposite reaction. This will be P1. For the other, it is in tension. So this will be P2. This will be P2. Yes or no? This will be P2. This load is P, this value is delta, this length is L, and this is your torsional value. Yes or no? So just need to write one point. This is plus plus. Tell me, Re Baba. Yes, you are analyzing for the bar AB, my dear friend. You are analyzing for the bar AB. So you need to look at the forces acting on bar AB. Is it correct? You need to look at the forces on the bar AB. So what are the forces? The spring is compressed, opposite force is applied on the bar. That is in the right. The spring is elongated, opposite force is applied on the bar. That is towards right. Is it clear to everyone? Now, so see here, P1 plus P2 into L, right? Minus P delta MA. What is the value of theta? What I can write as theta? Tan theta. It's a very small angle. Theta is what? Delta by L. So we will substitute this. So into delta by L. Is it clear? So now, what has been asked from us? What has been asked from us? It has been asked P delta is equal to P1 plus P2 into L. MA is what? What is MA? What is MA, my dear friend? What is MA? Okay, just a minute. So I can write this as KT into theta. Theta is nothing but delta by L. Theta is nothing but delta by L. So what is the value? What is the value, my dear friend? What is the value? I've written like this. Let me be clear with this. Plus MA is equal to 0. Plus MA is equal to 0. Now I'm writing like this. Is it clear now? Is it clear now? So just rewriting this. देखिए यहाँ पे. You have been told to find the value of P. You have been told to find the value of P. So if I look at the value of P, so P into delta, right, must be equal to P1 plus P2 into L. I substitute the value of P1. What is the value of P1? K1 into delta. What is the value of P2? That is K2 into delta. Yes or no? Multiply with L. MA. What is MA? KT into theta plus KT into theta is what? Delta by L. This is equal to P delta. Now delta cancelled out. Yes or no? So what is the value of P now? What is the value of P now? K1 plus K2 into L plus KT by L. Is it clear to all? Is it clear to everyone? Tell me now. Is it clear to all now? Just see here. Just see here again. Just see here again. What is happening? When you apply the load, it is going to, either you can see, either you can twist in the left or you can twist in the right. Just the direction will change. So I twist in the left. The load will be coming at B dash. I can see the spring in the left part to get compressed. So the force on the bar AB will be towards right. I can see the force in the right, the spring in the right part to get elongated. So the force will be towards which direction? Again in the right, on the AB. Now, so that value I've already written as K1 into delta, K2 into delta. Right? Now, my dear friend, what I did, I used the equilibrium. Where? At A. Summation moment at A is equal to 0 because I can see the lever arm. So clockwise I have taken positive, anti-clockwise taken as negative. So P into delta anti-clockwise minus. Here P1 into L, P2 into L clockwise plus. MT, that is moment at A, as positive because that is also clockwise. So now put the value, you will get this result. Anyone having any doubt now? Tell me fast. Anyone having any doubt now? Is it clear to all? So if this type of questions come, can you answer? If this type of questions come, can you answer, my dear friend? If this type of questions come, can you answer? Yes? Most of the questions you will find this concept itself. I hope you will be answering whenever it requires. Yes? Good, 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 good. Very good. Right. So, moving to the last question. Moving to the last question. Impact loading. My God. Impact load. Impact loading. Yes. High chances this year. High chances this year. Just see the question. Just see the question. Sir, have you learned anything like this before? Have you learned anything like this before? Tell me first. Have you learned anything like this before? Any formula related to this? Anything related to this? Have you learned anything? No? No? Never. So, sir, how to approach such question? How to approach such question? How to approach such question? If you don't know anything like this, I have taught you impact that is due to the bar subjected to the axial load. That is impact load. But how to solve such questions? Very easy. Energy concept. Entire external work done is stored in the body in terms of internal energy. Just giving you idea. When the load is applied, there is a energy. There is a energy, right? There is a external work done. This is going to settle by delta. This is going to settle by delta. This is going to settle by delta. Now fine. Now fine. You need to find the value of K. The spring also settle. What you can do, you can go for the equivalent concept. Springs are in parallel. Use the concept of energy, you will get your answer. Use the concept of energy, you will get your answer. You know how to find the energy. You know how to find the energy, use the energy concept. Just use that, get the value. Get the value. Use the concept of energy, my dear friend. Use the concept of energy. Last question. Give your best, my dear friend. Give your best. Don't be in a hurry to just complete. I've given some best 15 questions for you all. Right? Each topic I've taken, given you the questions on that. Tomorrow, sharp at 7 p.m., we'll be there with 19 to 20 more questions of SOM and 12 to 13 more questions on structure analysis. Till the time you clear your gate, we will be there to stand with you, my dear friend. Give your efforts, we are there. ARI at 27.5. You are getting the value of A, that is 27.5, right? Okay, let's see. 25, you are getting 25. Okay, let's see. Let's see. So entire external energy is going to stored in the body in form of internal energy. We'll assume there is no loss of energy. So use the energy concept. You know how to find the energy in the spring. You know how to find the energy in the spring. Just use that. You are getting A as answer. Let's see the solution. So my dear friend, the first part that what you can do is, you can make a single spring. The value will be 2K, right? When the springs are in parallel, we just add the spring stiffness. Yes or no? Yes or no? So 25 Newton, 100 mm. 25 Newton, the height of all is 100 mm. The height of all is 100 mm. So let us say this is W, this is H. Let us say this is W, this is H. And it settled down by delta. It settled down by delta. It settled down by delta. What is the external work done? What is the external work done? What is the external work done, my dear friend? That is nothing but W times H plus delta, yes or no? The external work done is nothing but W times H plus delta. Yes? It's not WH, Rishabh. It is W times H plus delta. Yes or no? And if I talk about the internal energy stored that is due to the spring is nothing but what? Half into force in the spring into delta spring. Yes or no? Half into force in the spring into delta spring. So what is force in the spring? What is force in the spring? Stiffness, that is 2K multiply with delta. And delta spring is nothing but delta. Is it clear? Is it clear? Tell me, my dear friend. Yes or no? Is it clear to all? So now if I equate, what I am going to see? K delta square must be equal to W times H plus delta. Put the value, you will get your answer. So you have been asked, what is the stiffness? K value. So delta is how much? 10 mm. So K into 10 square. What is the load? 25 into H plus delta. What is H? 100 mm. 100 mm plus 10. That's why I think your difference might be there. What is the value of K? What is the value of K? 25 into 110 divided by 100. Now you will get your answer. What is the value of K? 27.5. Now are you getting the exact answer, my dear friend? Now are you getting the exact answer? Newton per mm. Are you getting the exact answer now? If you miss a value, obviously the answer will be different. But although there is no such result closer to that, you have marked it, that might be correct. But I always say, what is the concern? The concern part is your concepts. So GW soldiers, have you enjoyed this 2 hours 50 minutes with the 15 questions that I've covered on GATE Wallah English? Are all the questions almost new to you all? Are all the questions almost new to you all? And the problems that you are facing in the test series, whether you are not reading the questions clearly, you are not practicing that much, you are at the end moment you are making some error, are all these points covered? Although these are the important topics, but what matters is your concepts are clear, right? Maza aaya? Good. Right. So I hope this will be maintained for long. We'll maintain this and we'll bring some more sessions. Be sharp at 7 p.m. tomorrow on Gate Wallah MEC HC channel. Right. And we will be delivering some very good questions, sir. These are basic level questions that what I thought that you should be knowing. You should be knowing. Spring is very small, Rishabh. Spring is very small. It's not big. Already discussed that spring in the lectures, right? So spring is very small. It's not that big. Just go through that. You will be able to cover. Okay. So thank you to all. meet you all tomorrow at 7 p.m. on Gatewala MEC and XC with some more brilliant questions, and you will love it. It's my guarantee. Right? So meet you all tomorrow. Till then, take care.